welcome to NASA Edge.
An inside and outside look at all things NASA.
Well, we're back here under the stay-at-home and sort of quarantine conditions that we're all facing, but we're not without content. We got a lot prepared for the show today with a special guest.
Yeah, we have NASA Chief Scientist Jim Green, who is a friend of the show. We have interviewed him many times, and we are so happy to have him on our show today.
Well, Jim, thanks so much for joining us on the program this morning. I got to tell you, we're all wondering, because we're all facing this, how are things going for you during these crazy quarantine conditions where we're all working from home?
Well, I'm working from home like everyone else, getting all the IT working. Things are going well. We're safe here, and my wife has a stockpile of food and toilet tissue. So what more could I ask?
Perfect. Wonderful. Well, I tell you, one of the reasons we wanted to get together and talk to you is back before all this craziness, you actually came down to NASA Langley Research Center and gave a presentation on NASA's search for life. And I was able to go to that presentation.
Yeah.
Fantastic. Yeah. Very inspirational. But one of the things it brought up is this whole idea is what NASA actually means by life when they say they're searching for life. So I was wondering, how does NASA define life?
Well, the astrobiologists really spent some time teasing that apart, and of course they wanted to be able to do that in a way that doesn't emphasize life as we know it, because there's all kinds of surprises out there that we have to anticipate in some way. So they came back and said life has three attributes, okay? So the first one is it metabolizes, okay? That means it takes in a liquid and food. That solvent then pulls the energy out of the food, and then the liquid is used also to eliminate waste. So metabolizes. The second part to that is it reproduces, and the third part of that is it evolves. And it's that simple.
Now, how do you determine something like whether an organism or a life form evolves? I mean, if you don't have a significant enough record of activity.
Yeah, indeed. So, when they told me that, I was really depressed because I can't build any instrument to go out and see reproduction and evolution. But the metabolism part is the critical one. So if we examine that more closely, we then say, okay, it requires a liquid. So let's do a little bit of an experiment and say, where can we go on this Earth looking for water? Because that is the key liquid here on Earth. And if we find water, do we find life? And so the astrobiologists did that, and they came back and said, yes, where there's water, there's life. And so that then started the theme of follow the water. And of course, we've been real successful in that. Then we ran across a place like Titan, okay? Titan was pretty spectacular in the sense that it was the only other body in the solar system with liquid on the surface, but it wasn't water, it was methane. And so that really got us thinking about, well, if there's life like we don't know it, like we have absolutely no idea, they're using a different kind of liquid, it'd be on Titan. And so that sort of raised the interest of Titan quite a bit.
Now, you mentioned Titan, which is in our solar system, but is there a possibility that we'll be able to search for life outside of our solar system?
Indeed. In fact, there's quite a few approaches that we're taking. And one approach, of course, is because in the solar system, we can actually go to these places. So missions like Mars 2020, which is now Perseverance, and Dragonfly is another one. Perseverance is going to Mars. Possibility of life there too, and Dragonfly is going to Titan. But in addition to that, we have missions like TESS, and of course Kepler in the past. Also, we're looking for planets that were Earth-sized, and then whether they were in the habitable zone or not, bringing up the question of whether they were Earth-like. And so, indeed, there's quite a bit of interest in looking for life out beyond our solar system into the stars around us.
And Jim, I know the big push here at NASA most recently is our return to the moon with Artemis, and I'm just wondering, is there a component of Artemis that involves the search for life, especially when we think of the sustainability of our presence on the moon?
Well, the moon has really come on as a fascinating object, more so than we ever thought, because in the last few years, maybe in the 5, 6, or 7 years, we have come to the realization that there's a fair amount of water in ice form that's trapped in these permanently shadowed areas in the northern and southern hemisphere. Now, it's not liquid, and so consequently we don't expect to find life there. But the water is really critical element for not only human exploration, because you can drink it. Water's water. It's H2O, whether it's on the moon or on the Earth. Okay. And you can tease it apart, hydrogen and oxygen. You can breathe the oxygen. You can tease it apart, and then hydrogen and oxygen used for rocket fuel. So it has a number of purposes. In fact, we estimate there's anywhere between 100 to 200 million tons of water in these permanently trapped areas. And so indeed, Artemis is planning to land on the South Pole, go into some of these permanently shadowed craters, core and pull out these cores, and then look for the water and all the volatiles and what's happened in the history. And why that's important and how that connects to life here on Earth is that we believe there was an era early on in the solar system where after the Earth and Moon were created, we were bombarded by a variety of water-bearing objects, like comets, like asteroids. And so that water signature is trapped in these permanently shadowed areas because they bombarded the moon too. And so that record will be really important to help us determine how perhaps water was delivered to Earth, which then is that essential ingredient that started life here. So there is a tie.
Now, Jim, this exploration of the moon you're talking about as part of Artemis, is the recent presidential order to mine the moon going to be a part of Artemis, or is that going to be separate?
Well, that's an exciting area to think about, because the moon may have an enormous number of raw materials that here on Earth, as we continue to mine those raw materials and use them and consume them, the moon would be the next logical step for us to be able to get access to those materials. The key is, well, how much is there? What is exactly there? And how can we get at it? And Artemis will be one of those missions, those early missions that gets down to the surface and gives us what we call ground truth. They can make those measurements. They can determine, if there's platinum group metals there, and look for some really important resources. So indeed, Artemis will be that step along the way for us to determine how we're going to use resources from the moon like that in the future.
Awesome, and thanks, Jim. We're going to talk a little bit about the search for life again later in the show, but before that, we did have some fans out there that wanted some updates on some key missions that are going on at NASA. So I wanted to know if you could give us an update on TESS, for example.
Yes. Oh, TESS is doing fantastic. Right now, TESS has got about 1,760 planet candidates that they've identified. Now, of course, how this goes is you see the transits, and then from those transits you decide on, yes, that's a planet, and it's a certain size at a certain distance away, and that makes it a candidate. And then there are follow-up telescopes here on the ground that then confirm, as they observe on a more regular basis those transits. What's happened right now is there's about 45 or so out of that list of confirmed planets. But we anticipate that number to grow radically, as we begin to confirm these planets. Not only that, the scientists have done a tremendous job. There's more than 240 papers that have been submitted for publication since TESS is launched. Not only looking for exoplanets, but actually studying these other solar bodies, these suns, in many different ways. For instance, one of the intriguing things that's got me excited is the fact that they've looked at some G stars. Now, our sun is a G2, so I'm saying they're basically looking at stars like our own sun, with huge sunspots on them. I mean, we're talking about maybe 20 degrees or more in size sitting on the sun. Now, we have nothing like that today on our own sun. So we want to know the age of those stars. Well, it turns out those stars are young suns. So this kind of research is really important because as they look at more G2 stars that are younger than our sun and really understand, the sunspot size, maybe the number, a few attributes like that, that tells us what our early sun was like. So Tess is doing fantastic. The science teams are just wonderful.
Hey Jim, this might be a crazy question, but can you tell through tests when a sun or star was born in relation to our solar system and our sun, where we are in as far as the evolution of that planet or that star?
Yes, it's done in many ways. Now, Tess looks at just the bright stars. So typically, bright stars are closer to us. All right. And so Tess has been looking at a number of stars that aren't very old at all, tens of millions of years old. Well, that's really young. Our star is, 4.5 billion years old. And so what they're looking at then are these early solar systems, these planets around these young suns. And that's really exciting. So they're doing really well in that area.
So Jim, the NASA EDGE team was going to return to Kennedy Space Center this summer to cover Mars 2020. Do you have an update on that mission?
Yes. Even though we're in this tough environment where we're sheltering at home and in place, we recognize that we're going to lose a window if we don't keep Perseverance, or Percy, moving towards that launch on July 17th. Now, the reason why that's so important for us to stay on track, if it's possible, and so far it is, and we can do it safely without, jeopardizing the people that are working in and around it. That's always been the critical question. That window opens for about 3 weeks every 26 months. So if we miss this July window, Percy's going to sit on the ground for quite a while. Now, Perseverance is a dynamite mission to Mars. This rover is huge. I mean, it's like Curiosity, looks like Curiosity in many ways. It has all new instruments. It has a rock core that then bores into the rock and creates that rock record. When I talked about going to the moon and getting cores in these permanently shattered regions so we could study the past of the moon and the Earth, we're going to do that with Mars. By bringing these cores back, we'll study what's happened at Mars. And of course, Mars at one time was a blue planet. We don't know how that climate changed, but indeed it lost most of its surface water. That evolution, that climate change happened, we think, very rapidly, and perhaps that rock record will give us the information we need to determine how that happened. So it's a pretty spectacular mission coming up.
Awesome. Well, listen, I tell you what, you have a very exciting program that you also do for NASA. It's a podcast called Gravity Assist. And I was wondering, from what I understand, you are going to do an entire season on this topic of the search for life. Tell us a little bit about that.
Right. Indeed, this is the 4th season for Gravity Assist. Our first episode is coming up now here in April. We're releasing it on Friday. The whole series is on that search for life. Now, I've already done a number of the interviews. I still have several planned. And of course, our current situation of being sheltered in place based on the coronavirus problems that we're having, it puts a little damper in that. But we are proceeding quite well. There are some really exciting discussions about finding life. And so you don't want to miss it.
Awesome. And for everyone out there, you can find Gravity Assist on most podcast aggregators like iTunes and others. But also, if you want to go directly to the NASA webpage, you can find it at nasa.gov/gravity-assist. So check it out. You don't want to miss it. Jim, thanks so much for being on the program this morning. We always enjoy talking to you.
My pleasure. Thank you.
Please go out and download and listen to all of Jim Green's Gravity Assist podcasts. You won't be disappointed. And when you're done, visit our Facebook fan page or our YouTube channel and let us know the kinds of topics you want us to look into as we continue under these stay-at-home conditions, because there's a lot going on at NASA that we still want to find out about. And Franklin, I'm wondering, have you had a chance to listen to Jim's Gravity Assist podcast?
No, I have not, but I'm going to add it to the queue of shows, podcasts, and TV programs that I'm going to watch over the next month or so. So I'm looking forward to getting into it.
Awesome. Well, it's certainly binge-worthy, that's for sure. So without delay, go out and download them and enjoy. It's a real treat.
You're watching NASA Edge.
An inside and outside look at all things NASA.